this module, you will learn about the physical properties of alcohols and phenols. Alcohols and phenols consist of two main parts: an alkyl or aryl group and a hydroxyl group. The hydroxyl group chiefly determines the physical properties of the alcohols and phenols. The nature of the alkyl or aryl group does modify these properties to some extent. The boiling points of both alcohols and phenols increase as the length of the carbon chain increases, as shown in the table here for some primary alcohols. This is due to increasingly strong London forces as the length of the carbon chains increase. What is the effect of branching on the boiling point of alcohols? Use the information in the table. The table shows 3 butanol isomers, which all have the same molecular formula. As the branching of the carbon chain increases, the molecules attain a spherical shape and the surface area decreases. As a result, the van der Waals forces of attraction become weaker, and therefore the boiling point decreases with an increase in branching. Therefore, among the isomers of butanol, tertiary butyl alcohol 2-methyl-propan-2-ol has the lowest boiling point, as shown in the table. Alcohols and phenols have boiling points higher than other classes of organic molecules, such as hydrocarbons, ethers, haloalkanes, and haloarenes, with similar molecular masses. For example, the boiling point of ethanol is considerably higher than that of methoxymethane or propane, although all the 3 substances have very similar molecular masses. Both alcohols and phenols can participate in intermolecular hydrogen bonds due to the presence of the polar hydroxyl group. Thus, alcohols and phenols have higher boiling points than ethers or hydrocarbons, which cannot participate in hydrogen bonding. Alcohols and phenol can both form hydrogen bonds with water, and so both are water-soluble. The solubility of substituted phenols is very low in comparison to phenol. It should be noted, however, that as the alkyl or aryl groups get larger, the solubility decreases. Ethanol and other low molecular mass alcohols are completely miscible in water. They can dissolve in water in any proportion. Let's apply our knowledge to answer some questions. Which of these molecules would you expect to have the higher boiling point? It's helpful to draw structures for these types of problems. Essentially, you need to determine which molecule in each pair has the stronger intermolecular attraction. For set A, 1-heptanol has the higher boiling point because it has the longer carbon chain. For set B, 1-propanol has the higher boiling point. 1-propanol with its hydroxyl group can participate in intermolecular hydrogen bonds, while the ether methoxymethane cannot. For set C, 1-hexanol has the higher boiling point. Its carbon chain is unbranched, giving it stronger London forces than the branched chain in its structural isomer 2,3-dimethyl-butane-1-ol. You have now reached the end of this module. In this module, you learned that the hydroxyl group chiefly determines the physical properties of alcohols and phenols. The nature of the alkyl or aryl group does modify these properties to some extent. The boiling points of alcohols and phenols increases as the carbon chain increase in length, but decreases as the chains become more branched. Alcohols and phenols have higher boiling points than other organic molecules. Alcohols and phenols are water-soluble.